Alright guys, here we go with our second day on equations. A little tougher today, it's just hang in there, take some good notes, and we'll get through it. First one, we're doing quadratics yesterday also, but this is the last kind of quadratic method. It's called the quadratic formula. You've seen it. There's a song, x equals negative b plus or minus the square root, b squared minus 4ac all over 2. You've heard it before. Here we go. X equals negative b, which is negative 12, plus or minus the square root of b squared, which would be 144, minus 4ac all over 2a. And I'm teaching you just like you've done it before because you have done it before. Okay, so I'm not going through every single little, which a, what's b, let's see, like I just did. Work out what's inside your parentheses there, or square root, sorry. And if you work it out, you get 0, which is kind of crazy, over 8, which really gives you negative 12 over 8, which is negative 3 has. Now, I'm going to be honest with you. That doesn't happen a whole lot. Usually you get radical answers and everything. The best time to use the quadratic formula is when you have a coefficient, a leading coefficient that is not 1. Once I saw that 4 in the front there, I knew I was probably going a quadratic formula as soon as I saw that. Okay, next one has fractions, right? 2 steps here to start this one. First of all, you need to tell what x cannot equal. Remember domain from the other day. X cannot equal 0 and x cannot equal negative 2. And that's important because if I get one of those two for my answer, I know that it doesn't work because that's what makes your denominator 0. Second thing you need is the GCF, which is x and x plus 2. What I'm going to do is I'm going to multiply every single term in there times x and x plus 2. If I do this first term, the 3 over x, what would happen is the x's would cancel. So that's going to leave a 3 and an x plus 2. There's the fraction's gone. The second term, the x plus 2's would cancel. So I'd have a 5x. The third term, nothing at all cancels. So I'd have a 2, an x, and an x plus 2. And once you do that first step, guys, all the fractions are gone. You're down now to a regular equation. So I'm going to distribute the 3 on this side. Right hand side, I'm going to distribute the 2x. Just like that. Now, it's a quadratic. I've got an x squared, which means I'm moving everything over to the right to see what kind of method I'm going to use. If I do those two right there, that's really 8x. If I move it over, it becomes negative 8x. And if I subtract 8x from that 4x, I get negative 4x. I'm also bringing this 6 over, makes it minus 6. Now, because they're all even, I'm going to divide everything up there by 2, make it a little simpler for me. And it looks like it might factor. I think I can go like x minus 3 and x plus 1. Looks good. So I get two solutions, 3 and negative 1. Make sure they're okay. They're okay because they're not those two. They're not 0 and negative 2. So 2 solutions there. Sometimes you'll get 2, sometimes 1, sometimes maybe none. All right, how about one with a radical in it? When you have a radical, if you can, this is key, if you can isolate it, you need to isolate it. So what I'm going to do on this one is I'm going to move the 1 to that side, make it 2x minus 1, and isolate this radical. And once you get the radical isolated, I want you to square both sides to get rid of that radical. So I'm going to square this whole, this is the key, the whole side, and square this whole side. Now the right hand side is very easy. If you square negative, it's gone. If you square square root, the square root goes away. Left hand side, we did this the other day. Square the first term, multiply them together and double, and square the second term, and you get that right there. Again, I got a quadratic, so because it's quadratic, I'm moving everything to the side with the square. So I move the x over, minus x becomes plus x, that's minus 3x. Move the 2 over, I get minus 1. I can't tell if it's going to factor or not. It actually does look like it's going to. So I'm going to do slide, divide, slide, just to double check. So if I slide the 4 over, and I'm gambling here a little bit, then I'm going to factor what's there, which is x minus 4, x plus 1. And don't forget, now you have to divide by the same number you slid, dividing by 4. That gives me x minus 1, and I'm going to leave the 1/4. I'm supposed to really slide that 4, but I'm really just looking for solutions, and I can tell the solution very easily looking at my parentheses. One solution is 1, the other one is negative 1/4. All there is to it. Okay, so if you have a radical, try to isolate it, then square both sides. This one, if you have a 4th degree, what we're going to do, anytime this middle exponent right here is half as big as the first one, it looks like a quadratic, so we're going to treat it like a quadratic. The first term is really x squared squared, and that's really 8x squared, 8x squared plus 8. So it's really a quadratic form. So what we're going to do is we're going to just choose a letter. Your book chooses w, so that's what I would do. And I'm going to rewrite it like this, w squared minus 8w plus 8 equals 0. And I'm just going to solve that. I'm going to act like it's a square, and at the very end, what I really did here is I'm substituting w for the middle term. I'm substituting w for that x squared. That's not going to factor. I'm going to complete the square, so we get w squared minus 8w. Move the 8 over. Take half of 8, which is negative 4, square it. You get plus 16 on both sides. And so this side I get w minus 4 squared. Over here I get 8. Take the square root of both sides. Get w minus 4. Here I've got plus or minus 2, 1, 2. Move the 4 over. And usually it would kind of be done right there, but that's what w equals. I don't need w. I need to know what x is, because that's x is in the equation. Now here's the deal, way back here at the top. W represents x squared. So I'm going to move this up just a little bit and put the x squared in. So x squared really equals this right here, which means x is going to be plus or minus the square root of all this. Now, when you take the square root of that, you cannot just take the square root of each term because there's a plus or minus. So we're just going to leave our answer just like it looks, which is kind of crazy looking, but that's okay. That's what we got. All right, same thing here. Just told you this is. I'm glad this is on here. This is the second one, just like we just did. The middle exponent. Hopefully you know that 1/6, sorry, is half of 1/3. So I'm gonna let my w this time be x to the 1/6. All right, so I'm gonna put w squared because 1/3 is twice as big as 1/6, plus w minus 2. And again, the only reason I'm using w is because that's what your book uses. Some books use z. Just depends on what you want to do. This is going to factor this time. It's going to be w plus 2 and w minus 1. So I get these two answers. I get negative 2 and 1. But again, that's what w equals. So x to the 1/6 really equals negative 2. X to the 1/6 equals 1. Now, the way you solve a fraction equation, like this fraction exponent is, you raise each side to the reciprocal power. So because I have 1/6, I'm going to raise this side to the 6th power. Over here, same deal, I'm going to raise that to the 6th power. Now, negative 2 to the 6th power is positive 64. 1 to the 6th power obviously is just 1. And there you go. So, two of these now. Anytime the middle term, exponent especially, is half as big as the first exponent, act like it's quadratic. Either complete the square, do quadratic formula, factor, get your answers, then substitute back in your x. All right, hopefully that's okay. We'll work on it tomorrow. Last one today, absolute value. When you do an absolute value equation, you need to expect to get two answers. You won't always. There's one case where you won't. There's one case where you get none, but usually you're going to get two, like almost all the time. So don't forget what absolute value means. Absolute value means how far away a number is from 0 on the number line. So think about the number 3. What numbers are 3 away from 0 on the number line? And the answer is 3 and also negative 3. They're both 3 units away, which means the absolute value, the 2x minus 5, could be 3, or it could also equal negative 3, because both of those numbers, 3 and negative 3, both have absolute value that are 3, because they're both 3 away from 0. So you got to solve both of them. So move the 5 over, that's 8. Divide by 2, you get 4. Same thing here. Move the 5 over, you get 2. Divide by 2, you get 1. So the two solutions, 4 and 1. Absolute value, almost always you will get two solutions. All right, a little bit heavier today, but you've seen all that before, believe it or not. You've seen every bit of that. You can hear my phone, I keep getting texts for some reason, but we'll work on it tomorrow like we always do. Look forward to seeing you. See you then.